These are Algebra 2 notes from section 11.1, which is on combinations and permutations. First thing we talked about was the multiplication counting principle, which says if event A can occur X ways and event B can occur Y ways, there are a total of X times Y ways they can occur together. Which is why it's called the multiplication and counting principle. We multiply X times Y. Quick example, if you think about the flipping a coin has 2 outcomes, and rolling a die has 6 outcomes. Together, there should be 12 total outcomes. So you could roll or flip a head and roll a 1, head and a 2, head and a 3, head and a 4, 5, 6, or you could get tail 1, tail 2, tail 3, tail 4, 5, 6. Notice a total of 12 different outcomes. Example 1 says when we're planning for a prom, there are 5 entree choices, 8 choices for side dishes, 3 choices for dessert. We get to choose 2 entrees, 3 side dishes, and 1 dessert. Question wants to know how many possible dinners could be served. So our first entree choice, there are 5 options. Our second entree choice, let's assume we can't choose the same entree again. You can't go steak and then steak again. So assuming I can't choose that same entree again, now I only have 4 choices for my second entree. My first side dish, there are 8 options. My second side dish, there would be 7 options, and the third one, there are 6. And my 1 dessert, I have a total of 3 choices. And the multiplication counting principle says to get the total number of possible dinners, we multiply those up. We've got 5 times 4 times 8 times 7 times 6 times 3 for a total of 20,160 possible dinners. The factorial symbol, exclamation point. This is read 5 factorial. This simply means we're going to start with 5 and multiply down until we get to 1. There is a factorial button on your calculator. We need 5 factorial. It's 5, and then it's under math. Scroll over to probability, and it's number 4. So there's 5 factorial, which is 120. Permutation and combination are very similar things. They are both a rearrangement of items. So we're going to take items in a set and we're going to rearrange them. A permutation is a rearrangement of items in which the order the items are selected is important. So if the order is important, it is a permutation. For a combination, it's also a rearrangement of items, but the order that the items are selected is not important. Order does not matter in a combination. So let's take a look at a couple examples here where we are simply trying to decide if a permutation or a combination is necessary. My first example says the number of possible three-letter words that can be created from the four letters P-H-I-L. Words is in quotes here. I don't care if they're real words. They don't even need to have a vowel in there. L-P-H. We're going to count that as a word. So what we want to do is we want to choose three letters, three elements. In this case, let's go with L-I-P. And then I want to choose the same three elements, but in a different order, P-I-L. And you want to be thinking, is this the same outcome or are these different outcomes? In this case, those are different words. Even though they have the same elements in them, even though they have the same letters in them, they're different words. So the order that I put the letters in does matter. Therefore, this is a permutation.
Daddy.
Part B says the number of possible groups of three that can be chosen from a group of 5 people. So what we want to do is choose 3 elements from the group. Let's call them Alice, Bill, and Chris. So let's suppose I say Alice, Bill, and Chris, you guys are in a group. If I choose the same 3 elements but in a different order, Chris, Alice, and Bill, you guys are in a group. Notice this is the same outcome. It's the same group even if I choose the students in a different order. So the order that I chose the students in does not matter in this case. This one is a combination. Part C, the number of different top 3 finishers in the Indianapolis 500. Notice if driver A finishes first, driver B finishes second, and driver C finishes third. If it is C, B, A, C is first, B is second, A is third. Those would be different outcomes. The order that I put the items in matters. It is a permutation. Next thing we need to talk about is how to find the actual number of items. The number of permutations of n items, choose R. So notice n is the number of available items. R is the number of items that are being selected or chosen. Notice R is always going to have to be less than or equal to n. You can't select more items than you have available. The formula for permutations is n factorial over the quantity n minus r factorial. The combinations formula is very similar. It has an extra r factorial on the bottom. So example 3 says there are 15 position players on the Boston Red Sox. Question wants to know how many possible batting orders could the team have. A batting order has 9 players. It's not something you would have to know. So we are choosing 9 players, A, B, C, D, all the way down to however many 9 is. If I choose the same 9 players but put them in a different order, these are considered different batting orders, even though they have the same players in them. Order is important. This is a permutation. There are 15 players that could be chosen. We are actually selecting 9 of them. This is the permutation of 15 items, choose 9. Using the formula, it is n factorial over n minus r factorial. On our calculator then, type in 15 factorial again is under math. Probability, it's number 4. And divide by 6 factorial. And that's a lot. About 1.8 billion. Notice we also have under math PRB, we do have a permutation and combination button. To evaluate the permutation of 15 items, choose 9. You type in the 15 first. You go to math, probability, number 2, and then type in the 9. And it gives us the same number. Example 4 says that 4 students are chosen from this class. This class had 23 students in it. To help complete a survey, we are asked how many possible groups of students exist. So we are choosing 4 students. Students A, B, C, and D are completing the survey, or D, A, C, and B are completing the survey. That's the same result, the same group, even if I choose the students in a different order. So this is a combination. We have 23 items, 23 students that could be chosen, and we are choosing 4. If this is a test or quiz, all I would need to see is this, as well as your final answer. Which is 8,855. Notice if you do use the formula, we've got 23 factorial over 23 minus 4, which is 19 factorial, times r factorial on the bottom. You do need to be careful here. 23 factorial divided by 19 factorial, 4 factorial. It's not giving me the right answer here, because what it's doing is it's taking 23 factorial, dividing by 19 factorial, getting an answer, and then timesing it by 4 factorial. So I need to make sure I have parentheses around my denominator there, so that I'm multiplying that together first. Insert a parenthesis there. So we multiply first and then divide, and it gives us the correct answer. Occasionally, you may have to do one of these without a calculator. This one asks us to evaluate the combination of 78, choose 76 with no calculator. Using the formula, we've got 78 factorial divided by 78 minus 76, which is 2 factorial. And then r factorial, 76 factorial also on the bottom. So 78 factorial is 78 times 77 times 76 on down, which I can write as 76 factorial. And I choose to stop there because that 76 factorial is going to cancel with the 76 factorial that's in the denominator right here. You could do 78 times 77 and then divide by 2. It's usually going to be easiest if you divide anything first. So 2 goes into 78 39 times. So all I need to do is 39 times 77, which we can do without a calculator. $3,003 is correct.